Hello and welcome. In this session, we'll explore how machine learning operators available in ERDAS Imagine 2018 can be used to classify raster data. Let's take a look at the training data and the raster we are going to classify. Both the raster data to be classified and the training data are loaded in the left viewer with the training data overlaid on top. The raster is a 4-band RGBN image and has quite a few land cover types. Some of the land cover types may not be easily distinguishable in the viewer. Some areas of the image are forested. Some parts of the image are cultivated with corn and wheat crops, and there are fallow and barren areas. There are also some water bodies interspaced in the landscape. We want to classify the pixels into these land cover types, and we are going to do the classification based on the pixel values of the 4 bands. The training data is generated by manually collecting sample points from the various land cover types that occur in the image. The attributes of the training data are displayed in the table at the bottom of the screen. In the table, you see that it has 8 attributes. The name attribute shows the land cover types of each point sample, and the last 4 attributes are the per band DN values of the raster. Since we are going to classify the raster based on its pixel values, the algorithm will be trained based on these 4 attributes. This is a very important point. Classification has to be done on the same properties of the data that you trained your algorithm on. Otherwise, you will not get good classification results. In this case, since the raster will be classified based on its pixel values, the algorithm will also be trained based on these pixel values. If your training data doesn't have the pixel values as attributes, you have to do some pre-processing work to extract the pixel values at the point location of the training data. As I said earlier, the training data also has a name attribute that specifies the class of each sample point. This will also be used during training to inform the algorithm what class each point represents. We'll train one of the machine learning algorithm with the training data and then use the trained algorithm to classify the raster data. I have already created a special model that does the training. Let's load the model and we'll discuss about it. I don't need this viewer for now. For this demo, we'll train the random forest algorithm. Random forest algorithm is one of the supervised machine learning algorithms we have introduced in ERDAS Imagine 2018. To train the random forest algorithm, we need to give the initialize random forest operator a training data and specify the attributes of the data that will be used for the training. We supply the training data using the features input operator. And to specify the attributes to be used for training, we use the select attributes operator to look through the available attributes in the training data and select the ones we want to use for the training. Let's double click on the attribute name support of the select attribute operator and see what we have. So the available attributes for this training data is listed in the available attributes section of the dialog, and we have said we'll use the per band pixel value attributes of the data to do the training. And an important point I want to mention here is that the attributes must be specified in the same order as the raster band order. So the DN value for the first band has to be selected first, followed by the DN value for the second band, and so on. I'll go ahead and select these attributes. I'll also select the name attribute, since that is the attribute that informs the algorithm what class each point represents. Hit OK, Now let's look at the initialize random forest operator. This is the operator that does the actual training. We pass the feature stream with the selected attributes to this operator and also specify the attribute which is to be used for identifying the class names in the class attribute name port. In this case, it is the name attribute. So let's specify that in the class attribute name. Name, and the other attributes will be used for the training. The final operator is a machine intellect output operator, which saves the training algorithm, which we also call machine intellect, to disk. Now let's run the model. The model has run and generated the machine intellect. We are now ready to do classification. I have a special model that does classification, and we'll load it and discuss about it. So I'll clear this. Saving. Open. In this model, classify using machine learning operator, which is at the center of the model, does the actual classification. It takes the raster data to be classified via the raster input operator. It also takes the machine intellect created during the training phase, and this is applied to it using the machine intellect input operator. And once the classification is done, a raster stream that has the classification results is passed to the raster output operator, which saves the raster stream to a file. Now let's run it. The process has completed, and now it's time to take a look at the result. Alright, let's load the output raster. I don't need this one for now. I'll do that, and I'll start a new viewer so that we can compare side by side. Good. I will expand the legend so that we can see all the classes. Can also bring up the attribute table of the raster. By doing a quick visual analysis of the input image, which is on the left viewer, and the output image, you can see that they in general follow the same trend, but there is a sand and pepper effect in the output image. This is because the classes in this image are similar spectrally. We can use some other indices that better separate them, or we can post-process the result to remove the sand and pepper effect by, for instance, doing a majority filter. Once you are satisfied with the result, you can continue to do a quantitative accuracy assessment. This concludes the session. Thank you for listening.